My name is Nick Hayes. I'm in charge of technology, and I'll just quickly go around the room. Jenny Albrecht is here. She's in charge of operations and technical support. Chuck Dunning is here. He's our VP of Business Development, and Joe Fillingham is here, and he has been in charge of information and data sciences for some time, and unfortunately today is his last day at Wellntel. He's taking his dream job at the NOAA starting on Monday. We're super sorry to lose Joe. He's been with us since the beginning, but we're really proud of him for the big leap he's taking into a really important job, and we'll remain friends, and he'll continue to support, at least in spirit. So this is Joe's last webinar. I will say that we'll be making announcements about a person who will not ever be able to step quite into Joe's shoes, but who will be joining the team in a similar capacity in the next few weeks or so. So with that, let me jump right into this presentation. We're going to talk about adding to and accessing information for models and other databases and websites using a couple of new product lines that Wellntel has recently offered. Before we do that, I want to spend just a minute talking about what we do in whole. We began as really a sensor company. Our first inventions back in 2013 were level sensors designed to be able to very simply be deployed on domestic and small ag irrigation farm and municipal wells for the purposes of collecting groundwater level data. And these sensors do it well. They do it in special ways with lots of extra bonuses. They're real time and track pumping and provide lots of nice operational metrics. But as we began to sell these products around the country, we realized that most of our customers were really more interested in buying sensors and networks so that they could deploy arrays in, for example, water basins that would provide real-time information about really water cycle health. Groundwater level could be considered to be the supply information in an accounting practice that includes supply and demand. Pumping might be demand, rainfall might be supply, and we're measuring how much is down there. And so we now provide networks all over the country. We're in 35 states. We've got 80 or so networks deployed, and we're reporting in real time when there are issues or reasons for concern or opportunities as it relates to the water source. And so what that lets people do, and our customers are mostly water districts, sometimes municipalities, sometimes farmers, sometimes ad hoc associations of citizens who get together to build networks, sometimes villages and counties, and sometimes businesses like mines and other intense water operators who need to have more information about what they're working with. And we help them, of course, manage it sustainably. So that's our offer. I'm going to point to Joe now. And the reason I want to do that is he is going to give you just a really quick tour of what we call our analytics dashboard, which is where network data is actually assembled and analyzed in real time by most of our customers.
Thanks, Nick. So I'm going to switch over the view to our analytics dashboard from the slide presentation. I'll just take a second for this network to load. Analytics dashboard is a tool that's focused on the network. When you log into analytics dashboard, you land on a visual and an interface that puts the focus right on that network. This particular network happens to be in southeastern Wisconsin in a village called Richfield. And it's one that was stood up by a local hydrogeology professor and is made up of domestic use wells that are, evenly and pretty well distributed throughout this community in a way that will help understand aquifer changes and contribute to better management of the water resource in this village. So when landing here, again, the focus is on networks, and you can get kind of an overview of the year-on-year patterns and changes and trends in groundwater level in wells. You can click between different wells and see the different patterns and information that's coming from these different wells. Some of these wells have been online for a number of years, and others have only come online more recently. This includes operational information as well. Of course, in this interface, you can dig into the real data that's being collected. This gives you, in the hydrographs feature, an ability to build a hydrograph of groundwater elevation or the depth to groundwater, whichever you choose. It allows you to aggregate these data on a time interval that's meaningful, whether it's daily, weekly, monthly, quarterly, something along those lines, and then change the plot in a way that makes sense to the visual that you want to create. Multiple wells can be selected from a network, and all those can be compared with each other in ways that are meaningful, including normalizations and things of this nature. Many other tools involved here, and one I'm just going to pick on really quickly because it highlights really the key function of Analytics Dashboard, and that is to be able to do a lot of the analysis and visualization of information, assembly of analytics and things of this nature that really are difficult to do on your own, or even as a team using traditional methods like spreadsheets or GIS tools or things of this nature. So we're trying to streamline that effort, and in hosting all the data in the cloud and hosting these visual tools in the cloud, we're able to create visuals that can be updated and modified and allow for very pointed questions, very pointed new insight to be generated that will inform management and inform research. So just a quick overview of really the capacity of the Analytics Dashboard, picking on something like a spatial contour map and being able to change that through time, but also looking at things like the raw information coming in from sensors and the network view and comparisons that can be brought forward from that. So with that quick 2-minute sample, I'm going to pause again and jump back over to our presentation and allow Nick to take back over and take us back to
Great.
the cloud-to-cloud component.
Great, thanks, Joe. So you can imagine that this tool, Analytics Dashboard, is a very powerful interface for interacting with data that might be collected from the field. And what that's done is that's put us in a place where we're now not just gathering groundwater level information with sensors, but we're also deploying surface water level sensors. We are receiving data now from other sensor arrays like flow meters and kind of anything you can imagine that might deliver time series data that could be important to understanding the water cycle. And on the other side, once we're assembling all of these different data types, it becomes important to share them. And so we have 2 new methods for leveraging water data to support customer decisions. And we've presented them as products on our website. One is called Water Data Management and one is called Water Data Exchange. And they both rest on the premise of an API or an application programming interface, which is the sharing of information between databases. So on the left-hand side, Water Data Management is really about assisting in the collection and the storage and organization of information from networks, including observations, sensor stations, kind of anything you can imagine that might be brought into it. So we call this adding to your water wisdom. And on the other side, API means sharing that wisdom by pushing data from the Wellntel cloud into other databases. And I'm gonna talk to some methods for doing that in the next few minutes. Joe, would you move to slide 5? So the key is the use of APIs, as I've mentioned, on either end, getting information into the cloud and then taking information out of the cloud. And the information that can be brought into the cloud can come from a wide range of types and sources. It can be history. Frankly, it can be 3-ring binders going all the way back to the 1940s, gathered by the old frontline scientists that have been observing water in the field for years. It can be observations, of course. It can be machine-gathered, instrument-gathered logs of data. It can come in the form of spreadsheets or notes. It can be an existing database, and those databases can be connected machine to machine through an API to get information into the Wellntel cloud. It can be proprietary, that is, It can be something that needs to be held in the private and is only available to the user of our AD and their networks, or it can be public data. What Joe didn't show you is that we use machine-to-machine links now to bring precipitation information from his new employer, the NOAA, right into our groundwater level analytics to be able to show how rainfall impacts groundwater level. On the other side, outbound API is the idea of pushing data for maybe the purposes of period reporting. That is, a monthly or quarterly report that has to go to a village board to inform decisions about permitting, or potentially a compliance issue with a regulatory body that enforces how many gallons might be pumped from a specific location, or what the conditions are in that location. It can be used for risk and business case reporting. And we can also inform through API other software tools that need the dense data that we can collect and bring together. And it might be water data, it might be climate data, it might be accounting information, right? What are the results of an ag business's pumping as it relates to production output? That can be information that is at least pieces of that information are pulled using API into other systems. Our reporting API can of course be used for modeling. So if you've got a groundwater model or a climate model and you need more ground truth to inform it, then we can connect and help you get that. And some clients are now beginning to inform public-facing websites with the private data gathered from Wellntel and third-party networks and brought into these tools. So you can see that they are two different ideas. Water data management is really about import, and water data exchange is really about export, but they have really meaningful uses. Would you hit the button and go again, Joe? So I'm gonna focus on what was on the left-hand side of the screen before. Water data management is an overview. Who's it for? It's for water managers and consultants like hydrogeologists and scientists who are challenged with huge and usually incomplete data sets, siloed in spreadsheets, contained in arrays of 3-ring binders, maybe coming from 7 or 8 different instrument brands that are incompatible with each other. Well, we can bring that all together and persistently store it and present it and help it and help with analysis from the day it's brought to the site. What is it? Water data management is automated or streamlined information assembly. In that assembly, if it's data that we're helping collect with our own sensors, well, we're stamping a degree of quality commitment on top of every data point we deliver, because that's part of how our network was created. But we can also help people understand whether information they've gathered in the past was potentially flawed or out of calibration or something like that. So it helps the process of thinking about information quality through assembly with each new input. It is a common suite of analytical tools and templates that can be used. What Joe showed in Analytics Dashboard applies to all information brought to Analytics Dashboard for the most part. And that's a growing set of tools. And its impact, of course, is to really eliminate the spreadsheet jockeying, the sharing of both binders and USB sticks, and the removal of risk and leave outs or manual errors that happens with that communication. And it lets our clients focus on value-added reporting and sharing information with stakeholders, and really, frankly, working on the next client who needs to know about water. So how does it work? Well, it's really kind of a 6-step process. Once we agreed that it was necessary to bring some class of information to your analytics dashboard, we'd help map the sites and organize the data types. Let's say soil moisture is a data type, and we've never collected that in the past. Well, we would make sure we're ready to hold it and do something with it. And we do that all the time. We have a growing data type library. We can add a new one any day. and it can be integrated with the rest of the archive. Once we've agreed on sites and data types, then we implement security credentials, which means the person doing the uploading, if it's manual, is known to be that person, or the machine doing the API pushes to our system is known to us, so that we know that we're getting from a trusted source and the information is reliable. We begin to organize history and upload information from history, and that happens one time and it's stored forever. We connect the machines, and then we continue from that moment on real-time collection, which is really the ongoing process. And of course, as that's happening, we will be working with clients to define new and interesting ways of visualizing the information. That is, we'll define the reporting protocol that they want to utilize as they move forward with a big pile of new information in this tool. That's water data management. Let's go, let's do one more slide on it. I just want to describe that no matter the source for water data management, a spreadsheet or a machine, we're going to provide tools, and those tools are listed here on the right-hand side. We're going to give you file format so you know how to get it there. We'll give you 24/7 access. Security and privacy is all built in. When we're connecting machines, we provide a messaging protocol. We provide API code so that you don't have to write it yourselves. And we do that in an operating system agnostic way. So if you're using Macs or PLCs or some other device in the field for collection, we'll be able to help you program it to do this work. And within water data management, there are unlimited data types, as I mentioned. Site management tools are in your hands, and there's this kind of continuous development of useful analytics and visualizations. That's the left-hand side of the chart. Let's spend 5 minutes on the right-hand side of the chart. Actually, Joe, you were going to do a quick...
yeah, why don't I jump in really quick, and I have a couple ideas of how I can demo a couple pieces here. So on the water data management side of things, Nick highlighted a couple ways in which that assembly is happening. And we can demonstrate a couple of those really quickly, or at least highlight a couple of those from Analytics Dashboard to kind of put a visual to that. One of those is picking on this Richfield network in Wisconsin again, and the fact that they have a long history of taking water level measurements of different types in this area that goes back much further than 2015, 2016, when Wellntel sensors became part of the suite of tools used to monitor groundwater here. And so what they've done is enabled, or we've enabled them to actually post data to our database using a simple upload function. And in that way, they're actually able to utilize, a giant list of locations and new sensors and things of this nature with appropriate IDs and everything like that to directly upload and persistently store that data with Wellntel, and then allow that data to be brought forward as part of their broader analysis tools. So for example, coming back to this hydrographs tab that we were looking at before, the same type of information can be brought forward as part of this, and that includes these secondary measurements that relate to the well Chirkauer well that we were picking on before. So for example, you have the manual tape down measurement of groundwater level, as well as the Wellntel sensor itself. I still have some of these aggregation periods selected, and that's just fine. But what I am going to do is just zoom out in time and kind of highlight the key component of this, and that is that there's a lot of history associated with the data that's being collected, and that history can be brought forward in a way that's really interesting and useful from the perspective of analyzing that network and understanding and putting trends into context. Another quick piece I'll highlight in terms of data assembly is connecting to these accessible databases. So for example, we provide the opportunity to connect to the USGS database of groundwater information, and Nick highlighted this as well, connecting to the NOAA Climate Data Center database and all of the weather stations that are in and around a particular network, and then querying and bringing forward using API tools the necessary hydrologic information from particular weather stations as needed. So right now I'm querying precipitation data from a particular location near this network, and then visualizing or seeing that precipitation data and providing tools in which that can be incorporated into other access points. So in terms of data assembly, there's just a couple of quick examples. One other example that Nick spoke to was the idea of posting data to the Wellntel cloud automatically from hardware in the field. I don't have a great visual example of that here, but the idea is similar to upload, and except for that you're removing this manual process of creating a file and then coming to Analytics Dashboard and posting it. That post is done via code and sensors and hardware in the field, and then the data can be accessed and populated in these visuals automatically. So a couple of quick examples that relate to that. I'm going to jump back to the deck, and Nick, let you take back over again on Exchange.
That's great. And I'm going to spend 5-7 minutes now on the other side of this, which is the export or the use of data that's already in Wellntel's cloud into other locations. And I know, Robert, what we just talked about here is not where you are. What we're about ready to talk about is a little closer to where you are. So let's talk about what Water Data Exchange is. This is a set of tools that are designed for water managers, operators, people who have wells, consultants and scientists who utilize models or other reporting tools and need quality information to inform decisions. It really is a secure encrypted API for transfer of information that's collected into this cloud and then brought other places. And the impact, of course, is that it delivers accurate and ample and reliable ground truth to make other things more accurate and more predictive and less latent and more actionable. Want to hit the slide? How data exchange gets started is a little similar to setting up data management. We need to identify useful and available data sets that are already in our cloud and the meta tags that go with them. We do this one time and as needed, but once we've done that, that lets us write a query. Actually, not quite. We also need to understand which locations we care about and which reference points in those locations we care about, and then we write our query. And that happens one time. The query hits an API endpoint. We connect to it in a permanent way one time, and then after that, it's simply there. We implement security credentials so that we know, so that the machine that we're delivering to knows who we are, and we know who the machine is that we're delivering to. And so we essentially lock down against our privacy commitment and proper security protocol. And then after that, continuous data exchange happens. I should say this is a GET API as opposed to a PUT API. The PUT API was putting data into our database. This API is getting information from our database. So there is some code that's required to do this work. And so you want to hit the slide? When it's time to write that code, we're going to provide guidance around creating a proper query to the proper endpoint to either get summary reports like period average data, location summaries, 20% of all the wells in Wisconsin are up, tagged filtered data information to not include pumping information, for example, or we can go at it with a complete time series requirement, just grab everything from the locations that are needed and plop it into other databases or websites or models. Here it would be geotagged based on lat, longe, and elevation and would be filterable, but on the other side as opposed to filtered within the query. And I think, Joe, you were going to spend some time just screenshotting that or showing what happens there.
I'm going to jump back to AD here. Thanks, Nick, and just demonstrate the interface within which some of the credentialing occurs, as well as just give a quick kind of UI demonstration of what some of the endpoints include. So Analytics Dashboard is part of a broader system. And if I back out of the dashboard itself and look at the broader system, you're going to see, because I'm logged in as an administrator, a number of different tools and components that are built into this system, that some staging components and production components. Obviously, users of this would just see the final output production components, as well as some of these API components that I'll come back to in just a second. Really quickly, I want to highlight that when a user logs in, they have the opportunity to see and create these credentialed API keys, or these credentials for APIs in the form of a API key. And so it's really straightforward to do this. You click your username and then add an API key to your account, and that key can be directly associated with different API tools that you wanna utilize. So for example, I'll just create another test key as part of this demonstration. I'll call it test key 3. And if I click OK, then you're going to be prompted to log in one more time, which is all good. And then you're going to have access to that key. So this key I won't actually use for anything. It's not a big deal, but you have that opportunity to copy that key and save it in a secure place so that it can't be accessed and it remains private. And it can be used as that credentialed access point for running those GET queries on our interface. So that's the key component. I'm going to go back over to content and just look at the API interface itself. So this interface is used occasionally by folks that are trying to get used to the concept of the API, or maybe doing kind of a one-time request for a narrow range of information. I didn't show this, but Analytics Dashboard has a number of downloading tools as well. So some folks, if they're looking for kind of a one-time request for downloading information, will use that. This particular interface is really for getting used to what the endpoints do and what the differences are between them, and running some test queries to get familiar with code. So for folks that are really familiar with writing some of these lines of code and can take the instructions that we hand you and then run with that, no problem. This interface may never be used at all, but it's a nice visual to demonstrate what we're talking about. So the readings endpoint as part of our system has a small list of filters, but this is that piece that Nick mentioned where you're really getting at the quote unquote raw information out of the database. So not filtered or aggregated information, but really that raw information. And so you want to input the amount of information, the start and end date of the information, and how you want that to be organized. Alternatively, there's the statistics endpoint where you're looking at various types of statistics that can be used to aggregate information. So whether it's an average, mean, min, max, or sum of information depending on the data type and how important that is to that particular data type. As well as the different periods that are available for doing these aggregations, and a number of other filter components, including some of the similar ones from before. So given that this interface is useful for understanding that and running some tests based on that, you can always click try it out and then put in some inputs and then execute that to see the JSON output that comes from that. And that JSON output can be used in different ways with a little bit of code to either load that information into another database, load it into some other visualization tool or a model. And it doesn't take much to do that. Most coding platforms will have a package that'll allow you to work with JSON output in a pretty user-friendly way without having to do a lot of work there. So with that, I'll pause again and then hand it back to you, Nick.
Great. So what we've done is we've summarized two ways of thinking about API as a tool in an effort to leverage information collected into the system. Of course, about water. The getting started summaries are very, very, very clear. If we're trying to push more information into Analytics Dashboard, then what we want to do is understand the quantity, the current condition of that data set. Is it analog or digital or not? What the data types are that we're bringing. We can plan around that, make the system ready, and the push can begin. On the other side, if we're trying to get information from this, then The questions are, what are the destinations? Who's the audience? Is it a machine? Is it a model? Is it another computer? Is it another storage mechanism? What's the objective? So we can help point towards summary or raw data. What's the architecture that sits on the other end? What's that machine look like? So that we can get started. And that is a summary of these product lines and capabilities. With that, I think we've gone just a few minutes long, but we also started a little late. So I think what we'll do is turn off the recording, and if there are comments or questions or feedback, we'd love to hear.
Perfect. Thanks, Nick. I'm going to stop recording right now.